Welcome, everyone. My name is Greg Ziemiecki. I'm a product manager on the data management team at Splunk. And today we're going to talk about building technology add-ons and more specifically, how to build them without reinventing the wheel every single time. Standard forward-looking statement disclaimer. So please take a moment to read it. So obviously what we cover today reflects current capabilities, not roadmap commitments. So here's the plan for the next 25 to 30 minutes. We'll start with a quick reality check. What makes TA development hard today and why it matters? Then the gold standard, Splunk's framework for what a high-quality TA actually looks like and how to assess your own add-on against it. After that, we go deep on UCC, so the primary framework for building modern TAs. And we close with a broader tool chain, testing CI, the tools that keep up quality high after day one. So by the end, you'll have a clear, actionable starting point. Before we talk about the problem, let's establish why this matters. Technology add-ons are the backbone of how data gets into Splunk. So nearly half of the enterprise data enters Splunk through a TA. So they collect it, normalize it, and surface all the knowledge objects, field extractions, SIM mappings, safe searches, so that everything else depends on. And there are hundreds TA on Splunk base, 1,000 more customer-built ones running on production right now. So every detection, every dashboard, and every alert that fires in Splunk is kind of ultimately downstream from a TA getting its job right. So that's why the quality bar here isn't optional actually. TAs comes from three places. Splunk builds and supports, I would say roughly 80 plus of them, right? That's changing. And those are aligned with core security and IT use cases. And they are covered obviously by standard Splunk support. The other part is like partners and vendors build TAs for their own products and obviously publish them to Splunk base. And developers, that most of you today build custom TAs for specific data sources with full ownership of the code, tests, and its lifecycle. So the important thing is that gold standard framework applies to all three, right? So whether you are a Splunk engineer, a partner, or independent developer, so the same quality bar is also available to you, right? And the same tooling, obviously, right? Supporting that quality. So basically, what does it look when teams are building the TAs without a standard? Say so first of all, it's like inconsistent practices. So like if there's no single source of truth, and every TA looks different, right? So different file structures, different approaches to error handling, for instance. So an onboarding a new developer to this kind of TA development process takes weeks, right, instead of days. So then we have like a testing gaps. So most TAs ship without meaningful test coverage, right? So no unit tests for modeler inputs, no SIM compliance validation, no regression. The first test is often in production, right? So then the knowledge silos, right? So the kind of institutional knowledge, how to do the TA development in that lives in hands of handful of people heads, right? So when they leave, the knowledge goes with them. As trivial as it may sound, like no CI/CD, right? So version control isn't universal for TAs, right? So automated pipelines even less so, right? So manual releases, no regression detection. It's sometimes the TA lives sometimes on the computers. And last but not least, a SIM drift. So the common information model is how Splunk normalizes, obviously, the data across the different sources, right? And that's the kind of foundation for almost every security detection, right? So when the field mappings break silently, the detections fail, right? So if any of those resonate with you, so you are then on the right session today. And obviously, the gold standard is our response to all of that. So it's kind of benchmark of best practices and essential capabilities for building high quality, reliable TAs, which are then published at Splunk base, but overall the gold standard is published at dev.splunk.com, right? So it's kind of organized around 4 pillars. And first one will be like development. So actually we're following best practices for development process and kind of technical implementation, right? So this is a quote from the documentation straightly. So it covers everything from using UCC as your framework, okay, to password storage, IP support, explicit time parsing, SIM normalization, and validated configuration files. Then you have testing. So we're use clear guidelines to prepare for and execute thorough testing activities. So this is a modular input test, B-tool validation, knowledge object testing, unit test, like kind of layered by priority. And then maintenance and supportability. So obviously we are kind of apply recommendations to enhance the user experience, and obviously streamline issue resolution. And for instance, think monitoring dashboards, right? That comes out of the box with our tooling, security scanning, and documented upgrade path. Then documentation. So kind of create clear, comprehensive documentation for both developers and users to ensure your add-on is easy to understand and use. Installation guides, SIM mapping tables, troubleshooting guide, state documentation, stuff like that. So the gold standard isn't a gatekeeping, I would say, exercise, right? So it's kind of framework you can adapt alongside your TA. So the goal of it is make what good looks like explicitly, right? So then automate it as much as possible afterwards. So how do you actually know where your TA stands? We are publishing a self-assessment. It's a structured checklist that covers our practices. So you can walk through it for any TA you're maintaining, and you'll get a clear picture of the gaps. This checklist asks things like, are you using UCC? Are your credentials stored in Splunk password storage, or they are hard-coded? Do your modular inputs have automated tests? Have you validated your conf files with the B tool? Does the TA support IPv6? Is there documentation your users can actually follow? Some questions on like more on the quality side. For instance, are you staying with the current UCC version, or have you defined explicit time parsing? Do you have monitoring dashboards? So customers can see what's happening with their data ingestion. So none of them are surprising requirements. So I think what makes the self-assessment really valuable is that it forces you to go through it systematically, right? Instead of assuming you're covered. So it's not a certification. There's no badge, no audit, no gate. So think of it as a mirror, right? Run it, find out where you stand, and decide what to fix next. It should not take more than 15 to 30 minutes, right? And the link is on the bottom over here. So what are the tools that are supporting that? So UCC framework. So this is where everything starts. So you declare your TA in global config JSON, and UCC generates the UI, REST handlers, modular inputs, alert actions, monitoring dashboards that we talked a second ago. So one config file drives everything. Then we have add-on factory UCC test, the framework for automated modular input tests. So if your TA has modular inputs, most do, at least those those that are ingesting the data. You need to end-to-end test that actually, right? So send data through and validate what comes out on the other side. So this framework does that against a live Splunk instance in Docker. B2, obviously, Splunk ships with this built-in tool, so it reads your conf files the same way Splunk does it at runtime, and flags any kind of syntax errors, and will keys deprecated stanzas. So obviously, run it early against your source files before things get packaged, and then the kind of catches in the class of bug that only shows up when Splunk tries to load your config. Pin spec, obviously, the final gate before Splunk base. That's kind of obvious. And what else we have? Obviously, pytest-splunk add-on, and that's I think it's very kind of important. It validates your knowledge objects, field extractions, SIM mappings, event types, tags, safe searches. So you write data samples, and the PSA replays them into Splunk, and tells you which fields pass and which don't. Unit test for custom Python codes. So it basically covers logic that isn't UCC generated, right? OSS SaaS dust tools for security scanning, dependency audits, and reusable workflow with add-on factory workflow, add-on release package, and we'll see that wires all jobs end to end. Yeah, and I think I can say that the results from applying those tools and criterias are really tangible. So we see consistently those three outcomes, right? So customers are seeing the higher SIM compliance, so the data are normalized as expected. It's easier to troubleshoot, better structured inputs, clear error handling, monitoring dashboards, and faster time to value. So one of the aspects is like better documentations. Customer can reach a working state faster. That's one of the example. And obviously, a huge portion of our Splunk supported TAs are meeting all of those gold standard criteria. UCC, Universal Configuration Console. So I would say this is the heart of the new modern TA development. It's a CLI-based framework that handles the boilerplate of TA development, so you can focus on the integration, right? So we describe it as you focus on the integration, and we provide everything else. And everything else means UI, REST handlers, Python scaffolding, monitoring dashboards, open API documentation, alert action templates, all of this from a single configuration file. So it's open source on GitHub. It's, like I said, it's used by us, by Splunk, for all new TAs and a large portion of the already existing maintained TAs. And the framework itself is actively maintained and supported. And there's also a community channel for external developers to reach #UCC-framework on Splunk user group Slack. One comment, UCC gen build, and this is what you get, right? So the configuration UI, Python REST handlers I mentioned on the previous slide for all, create, read, update, delete operations, modular input scaffolding with helper modules, Python library installations, including OS dependencies, out-of-the-box monitoring dashboards, which addresses these monitoring requirements, alert action files, all the structural files Splunk is expecting. Right, so you write the data collection logic, UCC generates everything around it. And moreover, obviously when you think of the development lifecycle, you need to have like those three comments in mind, right? So first, UCC gen init, so it scaffolds new TA, all the directory structure, starter, global config JSON, starter modular input. You're right. You start from working baseline, not a blank page. Then you have UCC gen build. It generates everything, so it runs this every time you change your global config JSON file. And then you see gen packages are installable targd for for Splunk, right? And right, so the workflow is edit global config JSON or run UCC gen build, everything regenerates. So global config JSON is your single source of truth. When you need to go beyond defaults, UCC has some extensions. So custom REST handlers. You can validate API keys on input creation, cleanup, KV store, on delete, and things like that. Custom UI extensions, JavaScript, CSS, injection, real-time validation, open API integration, so generated specs for CI/CD automation, and some additional packaging, right? Post-build Python scripts, executables, other executables, right? I would say the default covers like 80% of the use cases. I think the extensions it's more like 20% from our experience. If we make it even more concrete, so we are maintaining a Splunk example TA on GitHub. So this is a fully working TA built with UCC that is kind of demonstrating the every best practice we've covered. So you can clone it, you can read it, and you can build from it. The workflow from zero to package TA is like you set up virtual environment, install dependencies, obviously. Install UCC gen with all the other development tools, and then UCC gen build to generate all the TE files, right? After that, UCC gen package to produce the installable artifact, and that's some of that we already touched, but that would be like how we can build like a example TA from scratch. And the repo structure is actually showing JS aligned TA in practice. So global config JSON and the root. You are declaring everything, the package bin, your data collection logic, tests. So PSA tests ready to run, which are ready to run. GitHub workflows, right? So CI is already wired there. Docker compose for local Splunk for testing, right? So you just like clone it, build it, read the global config JSON. The file tells the whole story. pytest-splunk add-on, so PSA is like a gold standard tool for automated knowledge object test and official docs. How we name it, like test the knowledge object, sim compatibility, index time properties using pytest-splunk add-on, right? So you can aim for quite high possible test coverage, right? So Splunk example TA ships with PSA already wired and sample data included. So obviously, which removes a bit of this setup cost. And what this is validating, it validates field extractions, sim mappings, event types and tags, safe searches, index time properties. So the recommendation is like run it on every pull request, right? So the goal is like to have the highest possible coverage and to catch the sim regressions before they merge, right? Not after users report broken detections. Yeah, admin spec obviously mandatory. What I would like to it's for you to remember from this slide is obviously UCC generated TAs pass app inspect by default, right? If you see failures, they're coming from your custom code, right? I think that's a useful signal actually where the quality gaps are in fact. So 3 things to do after this session, I would say. So start your next TA with UCC, right? Go to Splunk GitHub, follow the quick start, or clone this example TA as your starting point. Next step, audit existing TA against the gold standard for your self-assessment and self-awareness. Go to splunkdev.com, walk through the checklist, 15, 30 minutes, you'll know exactly where your gaps are. Last but not least, pytest-splunk add-on. Yeah, if your TA has knowledge object, this is the highest value you can add, and the highest value you can make right now. Okay, so here's where we landed. The gold standard is defining what a high quality TA looks like, right? So it's published, right? So it has 4 pillars: development, testing, maintenance, documentation, and a concrete self-assessment you can run in 15 minutes. So UCC gives you foundation for that. One config drives your UI, REST, handlers, inputs, and monitoring dashboard. All the supporting tool chain, UCC test, tool, app inspect, PSA, that all maps to it. So UCC run the pipeline, ship a gold standard TA. Thank you so much. Hope you enjoyed that.